Think all sugar comes from sugarcane? Surprise! Some comes from roots, some from towering stalks, and some drips from flower buds. Beet sugar thrives in cold soil, cane sugar soaks up the tropical sun, and palm sugar? It's harvested from flowers, like nature's own nectar tap. They may all taste sweet, but these sugars take radically different paths to your pantry, and that's where the story gets interesting. Here's a sweet little secret. Palm sugar is still made by hand, drop by drop. Beet sugar quietly fuels most of Europe. And sugarcane? Well, it's the global giant. This is Food Factory Processes. And today, we're tracing sugar's journey from root, stalk, and blossom all the way to crystal. Ready to see how nature gets refined? Part 1. Sugar beet production. Cultivation and harvesting. If you thought sugar only came from the tropics, think again. Some of the world's whitest sugar begins underground, in the cool soil of spring. Sugar beets thrive in chillier climates. Northern US, Russia, much of Europe. By autumn, each root swells to nearly a kilo, with up to 20% pure sucrose, more sugar per pound than cane. Harvest machines glide through fields, chopping leaves and lifting roots. 13 rollers later, the beets are cleaner than your hiking boots on laundry day. Truckloads head to storage near the factory, kept fresh by cold air until processing begins. One season, one harvest, millions of beets, and inside each one, a story of chemistry and sweetness waiting to be unlocked. Washing and pre-cleaning. Before any sugar crystal forms, there's a test. Not all beets make the cut. At this stage, it's not just farming, it's evaluating sugar potential. Automatic probes dive into truckloads, pulling random samples like lottery picks. Inside the lab, it's all about numbers: sugar content, moisture level, impurities. Only the best beets get a ticket to the next stage. The rest? Rejected before they ever see the factory floor. Approved beets roll in, muddy, rough, fresh from the field. They're dropped into giant washing machines, rotating drums or screw washers, where they tumble and scrub like veggies in a spin class. Stones and freeloaders? Filtered out by sieves and traps. High-pressure sprays blast off stubborn dirt. By the end, they're clean, polished, and spa-fresh, ready for transformation. Slicing and sugar extraction. Here's a fun fact. Sugar beets aren't crushed like sugarcane. They're shredded with precision. Shape matters when chasing sweetness. These thin V-shaped slices are called cosettes. Think French fries, but headed for hot water, not ketchup. The cut opens them like sponges, boosting surface area so more sugar can escape. From here, things heat up, literally. Hot water flows opposite the cassettes, pulling sucrose from every slice. In about 90 minutes, most of the sugar dissolves into liquid. What's left behind is pulp, not waste, but a protein-rich byproduct. This gets turned into animal feed, closing the loop on a very efficient system. And what do we get? Raw juice, a golden, sugar-rich liquid ready for the next transformation. Purification and evaporation. What comes out of the diffuser may look sweet, but it's still far from pure. This raw juice carries along tiny particles, proteins, and natural gunk that sugar doesn't need. To clean it, factories create lime milk by burning limestone with coke. This milky liquid binds to impurities like a magnet. Then comes CO2, triggering a reaction that makes the impurities sink like sludge. What's left is thin juice, now cleaner and around 16 to 18% sugar. Next, it enters vacuum evaporators, giant chambers that gently remove water without burning the sugar. Stage by stage, the juice thickens into syrup, rich, heavy, 60 to 70% sucrose. Not pancake syrup, sugar syrup. Every degree of heat and pressure is precisely controlled. Too fast burns it, too slow wastes energy. Crystallization and centrifugation. This is where sugar begins to take shape, literally. Thick juice flows into giant vacuum pans where it's gently heated under low pressure. To get crystals to grow, the factory adds seed crystals, tiny, perfect sugar specks made in a separate process. As water evaporates, the sugar starts to cluster around those seeds, forming a dense, creamy mixture called massa cuite, part syrup, part solid sugar. Next, it spins. Massa cuite enters a centrifuge, which spins faster than a jet engine, separating sugar crystals from syrup. The leftover molasses is collected, some reprocessed to extract more sugar. Then comes the rinse. Hot water is sprayed over the spinning crystals to wash off any sticky residue and boost purity. The result? Pure, wet sugar crystals, fresh from the spin, ready for drying. But we're not quite at the finish line. Final touches. Fresh from the spin, sugar crystals may look ready, but they're still clinging to moisture. And that's a problem. Moisture means clumps, mold, and a shorter shelf life. So, they get the sugar equivalent of a spa day, a warm air blast, about 65 to 70 degrees Celsius. Just hot enough to dry them out without melting a thing. Then comes a cooling breeze to lock everything in. It stops any leftover moisture from causing chaos later. But even now, not all crystals make the cut. They're sifted through precision screens. Too big or too small get sent back for a redo. Only the perfect pore-friendly grains move forward. Next stop, the lab. Moisture, color, and purity. Each batch is tested to meet a stunning 99.9% purity. This isn't just sugar, it's engineered sweetness, consistent down to the crystal. Finally, it's time to get dressed. Craft paper pouches glide in, get filled with exactly 1 or 2 kilos, never a grain more, never a grain less, and sealed tighter than airport luggage. From muddy beet to gleaming grain, the journey ends here, ready to stock kitchens, sweeten recipes, and maybe even land in your coffee. Part 2. Sugarcane production, planting and harvesting. We've followed sugar from beet to crystal, but that's only half the story. Now we shift from root to reed into the sun-drenched world of sugarcane. Sugarcane thrives in tropical climates. Think Brazil, Florida, Louisiana, where heat, rain, and rich soil fuel its growth. Instead of seeds, farmers plant cut cane stalks, and after months of sun, the crop grows tall and juice-filled. Before harvest, some fields are still burned to clear dry leaves. Controversial, but it makes cutting easier. Then, the harvest. Mechanical cutters slice near the root, strip leaves, and chop the cane into billets. Each machine can cover over 500,000 square feet a day. The leftover leaves? Returned to the soil, a natural fertilizer in disguise. Washing and preparation. Before sugarcane can give up its sweet secret, it needs a proper rinse. Think of it like a spa day after a long trip from the fields. These stalks don't head straight to the juicer. First, they're blasted with high-pressure water jets that strip away every trace of soil, stones, and stray debris, faster than your car wash on a Sunday. Clean, but still too tough to process, the cane is then chopped into bite-sized pieces, about the length of a remote control. This step isn't just for convenience. It exposes the fibrous interior, making the next phase of juice extraction way more efficient. Juice extraction. Time to unlock the sweetness. These chopped cane stalks roll into a line of industrial muscles, giant steel rollers, each one squeezing harder than the last. It's like squeezing toothpaste out of a log. What's left behind is bagasse, a dry, fibrous leftover that's anything but waste. Factories don't toss it, they repurpose it. From eco-friendly plates to cow feed, bagasse is sugar's overachieving sidekick. But we're here for the juice. What we get is raw cane juice, sweet but cloudy, like a smoothie with too much pulp. First up, it's filtered through fine mesh to catch stray bits of bagasse. Then comes the heat. At 221 GF, microbes are gone, enzymes are tamed. It's like giving the juice a spa day before the real chemistry begins. Here's where science steps in. A dash of sulfur dioxide stabilizes the juice and keeps fermentation in check. Then, milk of lime joins the party, neutralizing acids and binding with unwanted proteins, turning them into solids we can easily remove. The juice is left to rest. Slowly, impurities drift down like snow in a snow globe. What settles becomes fertilizer. What stays above? Clear, golden juice, ready for its final transformation. Concentration and crystallization. Welcome to the concentration stage, where clarified cane juice becomes sugar syrup. Now it enters vacuum evaporators, giant chambers that lower boiling points to avoid burning the sugar. 2/3 of the water is gently evaporated, leaving behind a thick, golden syrup with up to 70% sucrose. Then comes crystallization. In the vacuum pan, seed crystals, tiny grains of sugar, are added. Just a sprinkle guides the syrup into forming perfect crystals. As the syrup cools, sugar molecules latch on. With constant stirring and precise temperature control, the crystals grow evenly. Too fast and they clump, too slow and you get sludge. The result? Massacuite, a sticky, heavy mix of syrup and crystals, ready for its next adventure, the spin cycle. From invisible juice to sugar, you can see and touch. It's where chemistry takes form. Centrifugation and cooling. Imagine a ride that spins so fast it can fling syrup from sugar. That's exactly what happens in the centrifuge. The thick mix of syrup and crystals, called massacuite, spins at over 1,200 RPM, faster than your washing machine. Centrifugal force pushes molasses through tiny perforations, leaving clean sugar crystals behind. To finish the job, a light water mist rinses off any sticky residue. Quick, efficient, and oddly satisfying. The molasses isn't waste. It goes on to flavor brown sugar, feed livestock, even make rum. Meanwhile, the crystals move on to drying. A warm breeze, like a spa day with purpose, removes every last drop of moisture, down to less than 0.2%. That's drier than the Sahara and perfect for a long shelf life. Next comes sorting. Vibrating screens sift the sugar by size, like flour through a sieve, but on a massive scale. Whether it's destined for your coffee, a bakery, or a sugar packet, each crystal gets its perfect form. Refinement optional. Raw sugar is sweet, but if you want that iconic snowy white finish, there's one more step: refinement. It starts with heat. The crystals are dissolved into hot water, forming melter liquor, a liquid sugar on a mission. Next, it's a deep clean. The solution flows through filters packed with sand, gravel, and activated carbon, like a supercharged Brita, removing color and trace minerals. Once crystal clear, the liquid is gently recrystallized, forming ultra-pure sugar once again. Then it's back into the centrifuge. Molasses out, pure crystals spun to perfection. The result? Bright, white sugar, 99.9% sucrose, no bleach, no shortcuts. Just clean, classic sweetness, ready for your latte or birthday cake. Packaging and distribution. From raw cane to crystal perfection, now it's time to send that sweetness out into the world. For factories and soda giants, sugar ships in bulk, giant sacks over a ton. For your kitchen, neat 1 to 2 kilo bags, sealed by high-speed machines cleaner than most kitchens. And those tiny hotel sachets? Same sugar, just travel-sized, produced at up to 2,500 packets a minute. Before anything leaves, lab teams check sweetness, size, moisture, and purity to meet the gold standard. Then it's off, rolling from factory floors to kitchens, cafes, and corners of the globe. Part 3. Palm sugar production. Sap collection, tapping. From the towering stalks of sugarcane to crystals bagged and boxed, our journey through cane sugar ends here. But sugar, as it turns out, has many origin stories. Let's follow another. Far from fields and factories, sweetness begins in the treetops. Welcome to the world of palm sugar. Here, harvests aren't driven by machines, they're climbed for. Each morning, farmers scale trees over 20 meters tall with bamboo tubes and tradition in hand. A careful cut on the flower stem lets sweet sap, called nira, drip slowly into the tubes. No pumps, no pipes, just gravity and skill. To gather enough for one batch, this ritual repeats across dozens of trees, twice a day. Timing is everything, and rain can ruin it. And once the sap is collected, the clock starts ticking. Sap preservation and boiling. The sap may be sweet, but it's fragile, fermenting fast in tropical heat. To slow things down, farmers use lime water, not the fruit, but calcium-rich liquid, to preserve clarity and hold off sourness. It's like giving sugar water a fresh start. Next comes heat. The sap is poured into wide pans over glowing embers. No timers, no tech, just watchful eyes and steady hands. It's stirred constantly. Miss a beat, it burns. But with care, the water evaporates and golden syrup begins to form, like reducing a sauce that's destined to be candy. The scent deepens, smoky, earthy, sweet. Locals even name the stages. Cow urine, when pale, senna flower, as it turns golden, and catching puyu, when the bubbling says it's almost done. Concentration and caramelization. From here, the real transformation begins. The golden sap thickens, folding into itself like honey learning to stand. As it boils, water evaporates, flavors deepen, and the sweetness takes on rich, smoky notes. Less maple syrup, more forest toffee. Old-timers don't rely on timers. They read the bubbles. When they darken and wrinkle, it's go time. The trick? Cook it just enough to hold shape, but not harden too soon. It's a delicate balance of heat, instinct, and experience. Molding and cooling. When the syrup reaches just the right thickness, smooth, sticky, and slow, it's time to give it shape. Carefully, the liquid gold is poured into molds, sometimes bamboo rings, sometimes coconut shells, sometimes just carved wood passed down for generations. As the mixture cools, it begins to set, solidifying into rich amber discs or blocks. No fans, no freezers, just time, shade, and a little breeze doing what they do best. And just like that, the once fluid sap becomes something you can hold, store, shave, or melt again into magic. These rustic blocks are more than just sweet. They're edible echoes of fire, flowers, and patience. Drying and packaging. Once molded, the sugar takes a moment to breathe. Laid out to dry, these caramel-colored blocks slowly shed their final bits of moisture, firming up, deepening in hue, and locking in flavor. Now, each piece is carefully demolded. If done just right, it slides out clean, smooth on the bottom, slightly wrinkled on top, like aged leather or the skin of roasted fruit. From here, it's all about format. Some stay whole, perfect for slow melting in sauces and broths. Others get grated into golden granules, ready to sprinkle over desserts, stir into coffee, or pack into jars. And finally, it's packed. Sometimes in leaves, sometimes in jars, but always by hand, with care, pride, and a little nod to tradition. From the heights of palm trees to the heart of the kitchen, this sugar carries more than just sweetness. It holds stories of trees, fire, family, and food. Part 4. Stevia sugar production. Cultivation and harvesting. Nature gives us sugar in more ways than one, but not all of them come with calories. Enter stevia, the sweet leaf with zero guilt and a whole lot of history. It all starts with a small seedling. Stevia rebaudiana loves warm, sunny weather and well-drained soil. Think of it like the Mediterranean of plants. Give it the right conditions, and it'll thrive year-round, giving you up to 3 or 4 harvests a year. Harvest time? Early morning. That's when stevia's natural sweeteners, called glycosides, peak. Imagine the flavor at its loudest, clearest note. That's what growers are after. Once picked, the leaves need to dry, and how you do it makes a big difference. Sunlight is free and simple. Ovens? Faster, but risky. Too much heat and you lose flavor. The sweet spot? A food dehydrator. Low heat, slow pace. Like air drying your favorite shirt. It keeps everything intact. After drying, the leaves are sorted. Big ones are kept whole. They look good and sell well. The smaller pieces? They're destined for something even more exciting. But that's in the next step. Extraction of steviol glycosides. Dried leaves might look lifeless, but inside, they're holding back a sugarless secret. To unlock it, just add heat. When steeped in hot water, stevia leaves release their natural sweetness, like brewing tea if your tea could sweeten your coffee. But just like tea leaves, we don't want the grit. So we filter the liquid, removing stray particles, twigs, and fibers. What we're after is clear, clean extract. Everything else? Compost or cattle feed. At this point, the juice is sweet, but still crude, so we give it one more polish. Using purified water, or sometimes food-grade alcohol, we separate the steviol glycosides, the true stars of the show. Then we remove the solvents entirely, leaving behind a syrupy concentrate of pure plant power. Advanced purification techniques. So far, we've gone from leaf to liquid. But if you want clean, crystal-clear sweetness, there's one more round of polishing. This is where the magic of science steps in. Using materials like ion exchange resins We filter out the final stubborn impurities, kind of like a Brita filter, but for molecular junk. Once purified, we move to concentration. Think of it like simmering soup, but under low pressure. So we keep the good stuff and lose the excess water or alcohol. What's left behind? A dense golden concentrate. Sweet, stable, ready for liftoff. And here's where it transforms. Using spray drying, that thick syrup is turned into a light, airy powder. It's like turning honey into snowflakes, fast, precise, and elegant. The result? Stevia in its purest, most shelf-stable form. A powder so fine, a pinch can sweeten a pitcher. Final processing and product formulation. It starts as a golden syrup, but here's where things get sharp. As the extract cools, it begins to crystallize. This is where we hit that magic number, 95% purity or higher. Pure steviol glycosides shaped into tiny, powerful crystals. On their own, these crystals are strong, too strong for most recipes. So, they're blended with other natural ingredients, like erythritol or maltodextrin, to make them easier to use, teaspoon for teaspoon. Once blended, the mix heads to packaging, and the variety is endless. Single-serve packets for your morning coffee, zip bags for the pantry, shaker jars for baking. No matter the size, every pack is carefully measured, sealed, and shelf-ready. From backyard harvest to polished powder, stevia's journey is a sweet one. Literally. It's not flashy. It doesn't melt like cane sugar. But every sprinkle is a reminder of what nature, science, and a little patience can do. 0 calories, 0 compromise, and a whole lot of sweetness, crystal clear. Beet sugar, cane sugar, palm sugar, stevia. 4 origins, 4 journeys, 1 universal craving. From mechanical might to quiet boiling pots, from ancient palms to modern greenhouses, we've seen just how much work goes into every grain of sweetness. This isn't just about taste, it's about culture, craft, and chemistry. So next time you tear open a sugar packet or sweeten your tea, you'll know, not all sugars are created equal. What surprised you most? Was it the muscle behind cane milling or the gentle art of stevia drying? If this journey changed the way you see your sugar, imagine what's behind the rest of your pantry. Don't forget to like and subscribe because Food Factory Processes is just getting started.